Graphing quadratics in standard form. All right, let's see what this worksheet has. So this is the first two problems in the worksheet. We'll tackle one at a time and we'll go from there. All right, so we're going to do a few things here. We're going to identify the vertex, the axis of symmetry. We're going to find our y-intercepts, and we're going to find the x-intercepts of each, and then we're going to sketch them. All right, so first question. So we take the vertex here. Let me just take this one more time. And that way we'll just have this. Okay, and we'll delete that. We'll just take the equation. Alright, so vertex. Alright, so what we've learned from vertex. Alright, so the vertex can be found by giving you the x value only of the vertex, right? This is the negative b over 2a. Right, so there's a little formula for the vertex. Alright, so what's your a, what's your b? So I'm just going to write my a is here. My a is 1. My b is 6, and my c is 5. Alright, so a, b, and c, right? These are my coefficients in front of x squared, 6, and then my constant 5 at the end. So the vertex can easily be found by just taking the opposite of b, which is the opposite of 6, and dividing it by 2 times 1. Finish this off, you get negative 6 over 2, and this gives you negative 3. Alright, so be careful here because the vertex is a coordinate, right? So there's an x-coordinate and there's a y-coordinate. So to find the y-coordinate, you have to physically plug in negative 3 into your function. So you have negative 3 squared plus 6 times negative 3 plus 5. Alright, continue this down. You get 9 minus 18 plus 5. So that's negative 9 plus 5, which is then equal to negative 4. So your vertex is negative 3, negative 4. So on my x-axis and y-axis, I'm going to go left negative 3, 1, 2, 3, and down 1, 2, 3, 4. All right, so there is my vertex. All right. We've also looked at this point, we found a is 1, so if a is positive or a is greater than 1, then you know this U shape is going to go up somehow, right? Because the a is a positive 1. All right, but let's see exactly where it goes, and then we'll go from there. All right, so then what? So now we have our vertex. The axis of symmetry, once we figure out the vertex, okay, so the axis of symmetry is going to be based off the x-axis, the x value of the vertex. So the axis of symmetry, I'm just going to abbreviate this, AOS, is going to be x equals negative 3. So the axis of symmetry is an equation, and I'm going to draw a line at x equals negative 3, right? So I'm just drawing a line here, so my whole graph's going to be symmetric about that axis, all right? Then, so we have the vertex, we have the axis of symmetry, the other piece we're missing is the y-intercept. All right, so the y-intercept is very easy to find as well. So plug in 0 for x, and that's just going to give you 0 squared plus 6 times 0 plus 5, and so now f of 0 equals 5, so f of 0 is a coordinate of 0, 5. So 1, 2, 3, 4, 5. All right, and now what this also is going to do for you is, since you have an axis of symmetry, this 0, 5 is 3 units from 1, 2, 3 from this axis of symmetry. So if you go 1, 2, 3 the other way, you'll get another coordinate there, and you can easily erase those lines there, and you can easily verify that coordinate. So you're saying here's negative 3, 4, 5, 6. So this is saying f of negative 6 is also going to equal to 5. And you can plug this into the equation and see if that is true, and guarantee it's going to be true. Okay? So the next piece in, and we have a y-intercept, we have axis symmetry, we have a vertex, right? This one's the vertex, this is the y-intercept, and now I want my x-intercepts. All right, so this is where this is where we set the equation equal to 0. So let me clean this up a little bit. All right, I'm going to move this over a little bit. Actually, we could do this right here. So I'm going to write, so for my x-intercepts, we'll do this piece right here. Okay, so we have x squared plus 6x plus 5 set equal to 0. This is going to factor into x plus 1 and x plus 5, right? 5 times 1 is 5, and 5 plus 1 is 6. So those are the factors of 5 that give you 6. Once I'm here, then I'm going to take each one of these factors, set them equal to 0, and this is finding my x-intercepts or finding my roots. So x is equal to negative 5, and x is equal to negative 1. So here's negative 5, and here's negative 1. And that's my x-intercept. That's another x-intercept, right? And I could also call these my zeros of the function, okay? Or another word can be my roots of the function, right? So any one of those would be suffice for using your words. And then you could just give yourself a little U-curve here. And again, this is a free sketch, right? And then you'll have a shape there with a vertex, 2 x-intercepts, y-intercept, and another random coordinate here that I got from the symmetry. You could also verify that your x-intercepts here is 1, 2 units to the right, and 1, 2 units to the left, right? So that's also symmetric about the axis of symmetry here, right? This is the axis of symmetry. All right, and that's pretty much it. So we've identified the vertex, x-symmetry, the y-intercepts, x-intercepts, and we've graphed. Done. All right, let's take the next one. So the next one is here. We'll steal this picture quick, and we'll move over 2 slides and paste this in. All right, so f of x equals 2x squared plus 20x plus 42. So now we have a leading coefficient of 2. All right, that's not going to affect my vertex at all, right? So vertex. All right, the vertex, I'm still going to find the x value of the vertex, so that's also going to be a negative b over 2a. I'm going to identify my a as 2, my b is 20, and my c is 42. So this is negative 20 over 2 times 2, or negative 20 over 4, or negative 5. So the x coordinate of my vertex is negative 5, comma, something. All right, now let's go get the y value. Let's go get the y value of the vertex. So let's plug in negative 5. So equals 2 times negative 5 squared plus 220 times negative 5 plus 42. All right, order of operations, negative 5 squared is 25. 25 times 2 is 50. Plus 20 times negative 5 is negative 100, and then plus 42, right? 50 plus negative 100 is negative 50, and negative 50 plus 42 is negative 8. So my vertex is negative 5, negative 8. So 1, 2, 3, 4, 5, negative 5, and 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's my vertex of negative 5, negative 8 vertex. All right, so that's the bottom of my U there. My y-intercept here, okay, so, oh, I'm sorry, so before that we have the axis of symmetry, so axis of symmetry. All right, the axis of symmetry is going to the equation, it's always going to be x equals, and it's always going to be the x coordinate of the vertex. So x equals negative 5, and I'm going to draw a line there, dotted line usually, to show that that's my line of symmetry here, okay? All right, then we have our y-intercept. Also very nice and easy for us. F of 0 equals, all right, and you can go through the motions here and plug in 0 for the x's, but what's going to happen is when you plug in 0 for x, x is going to cancel out and turn into 0, and 0 times 2, and 0 times 20, and you're just going to be left with 42. So your y-intercept is 0, 42. Now, my graph only goes up to 10, so I know it's going to be way up there somewhere. So I'm just going to not bother graphing that one just yet. And then we have our zeros of the function, right? Our zeros, or our x-intercepts, or our roots, right? All synonymous for one another. And we're going to take this equation, 2x squared plus 20x plus 42, and I'm going to set this equal to 0. So the first thing I want you to recognize is there is a leading coefficient of 2, which sometimes makes the factoring harder, unless 2 is a factor of 2, 20, and 42. And in this case it is. So if I factor that out, I'm left with x squared plus 10x plus 21. Well, that just made life a whole lot easier, because when I divide by 2 here, right, I get rid of the 2 and I'm left with 0 over 2, which is just 0. So that's going to make that nice and easy. So I'm just going to divide by 2, and that's going to equal 0 here. So now I'm going to factor this, and this 2 is not going to affect my roots at all. So now I need the factors of 21 to add up to 10, right? And nicely, x plus 7 and x plus 3. 3 times 7 is 21, and positive 3 and positive 7 adds up to 10. Set each one of these equal to 0. Okay, let me just do this a little bit and bring this up. And now I get x is equal to negative 7, and x is equal to negative 3, and those are my roots. So here's my 1, 2, 3. Okay, there's my first root. This is negative 5, negative 6, negative 7. So here's negative 7. Here's negative 3. So there's my graph going through those two coordinates here. All right, if you want to give yourself one more coordinate, that's fine. All right, so if I find any one of these, so I'm at f of negative 5. So if I find f of negative 4, f of negative 4 is going to be the same answer as 1 to the right and 1 to the left. So f of negative 4 will equal f of negative 6, right? Because of my symmetry here. All right, and you can, it doesn't matter at this point. I'm just going to use, if you had your Y-intercept, that's great. If not, that's fine too. All right, but let's plug in negative 4 and see where we're at. So f of negative 4 I'll do here on the side. Here in the bottom, f of negative 4 equals 2 times negative 4 squared plus 20 times negative 4 plus 42. All right, and so I'm going to get, so here this is going to equal 16 times 2 is 32. That's going to be minus 80, and then plus 42 here. And this is going to give me negative 6. All right, so I'll have 32 and 42 is 74, positive 74, and negative 80 is a negative 6, and that should be 1, 2, 3, 4, 5, 6, negative 6 here, and then that's f of negative 4. F of negative 6 is also going to be that same negative 6 here. All right, so now I just have a general shape to my graph here. All right, now I can see where my U is going. All right, I've identified the X-intercepts. I've identified 2 random coordinates here. My Y-intercept is way off my graph here. I don't have enough room for that one. If you're using a graphing calculator, you'll be able to see it. But we got everything that we've asked for. And there's graphing 2 quadratics or parabolas in standard form. All right, stay tuned. We'll be back for a couple more examples in Vertex form. Talk to you guys soon.